Hello everyone, my name is Dominik Plšek. I'm a staff engineer at Productboard. My journey with Productboard started almost 4 years ago. During that period, we have seen significant transformation in our approach to backend architecture. Today, I would like to share our journey, history, and learnings with you. I've divided this presentation into two sections. Initially, we will discuss our architectural history and touch on our key architectural milestones. In the second part, I will share some insights from extracting functionality from the monolith. Why this structure, you ask? Well, oftentimes, we are so entangled in the engineering part, in the design patterns, in the technology used, that we overlook the context they are used in. That's what we are trying to avoid here. But first, let me introduce Productboard to you. Productboard is a product management system that empowers teams to deliver right products to the market faster. It helps product managers to prioritize what to build and rally everyone around the roadmap. We have a concept of boards, such as insights board, features board, and roadmap. The cool thing about Productboard is that the data on all these boards are synchronized. So if an engineer updates a status of an epic in Jira, the linked feature is automatically updated on your roadmap shared with the stakeholders. Now, let's hop onto the time machine and get into some Productboard history and touch on key architectural milestones. Flashback to 2014, Productboard was incorporated. The team chose monolith-first approach to speed up the development and find product market fit. Keep it simple, stupid, right? Plus, the usage of Ruby programming language and the Ruby on Rails framework was on the rise. The following years were all about growth, and growth. Our front-end and back-end applications were growing, and we were rapidly developing new functionality on top of the existing one. Then, we hit a period of hypergrowth. As our organization expanded, we began encountering issues, some due to the prior technical implementations, and others due to the shared implementations, which lacked clear ownership. We also faced challenges in hiring Ruby engineers, even as we prepared the company for even faster growth. So we formed our first team to define microservice strategy at Productboard with the aim to lay the groundwork on which we will build our future systems. And now we can take a look together what are the key architectural pillars of microservices architecture. Each microservice should exclusively focus on its designated task. Independence between services should be maintained as much as feasible, and related operations should be consolidated into the same service. On the opposite side, there are anti-patterns we wanted to avoid. You should always try to avoid a situation where multiple services share the same database schema or table. Each microservice should manage its own data. Avoid creating dependencies where a change in one service leads to a change in another. And don't neglect the latency, synchronization needs, and transaction management in inter-service communication. This can lead to severe issues. And to circumvent those, we have adopted non-blocking asynchronous communication through Kafka between services, and adopted also data duplication between each service. This also had a benefit for us, as it allowed us to develop each service independently. So we decided to go full throttle with microservices. But first, we needed to draw the right lines which will map to context to the service. Actually, Martin will discuss domain-driven design more in detail, so I will not spend too much time on this. Yeah, and during this period, we also shift our hiring focus towards Kotlin engineers due to their expertise with distributed systems and wider talent pool. Despite the technology diversity that microservice architecture offers, we wanted to leverage the foundations and the knowledge we had built to boost team productivity. So we laid down engineering guardrails and made Kotlin with Spring Framework the primary choice for backend services at Productboard. This brings us to 2022, the year of contrast at Productboard. We have secured Series D funding and joined the Unicorn Club. However, we also faced challenges, including layoffs and significant organizational changes. Amidst a tense macroeconomic climate, we had to stay afloat and prepare what lays ahead. And this brings us to 2023, the year of focus. We are following through on the changes that started last year, covering both the architectural and organizational changes. Our approach is to double down on key initiatives while deprioritizing the rest. One well-known trade-off of microservices architecture is the operational complexity. We decided not to get caught up in the complexities of running services, housing domains we won't be investing in at the moment. This led us to consolidate some of our services while making sure we don't fall back into the big ball of mud again. So how are we going to do that? We are betting on monolith to design modular system while lowering the operational complexity. Monoliths offer advantages, including the identification of module boundaries, speedier iteration through in-memory communication, and simple core adjustments. However, they present trade-offs, such as diminished individual scalability and the hazard of introducing dependencies amongst the modules. On top of that, there's necessity to deploy the whole monolith as a single unit. Despite these trade-offs, we believe that monolith architecture can hold significant potential for our progress. There are numerous ways to build a well-structured application, and today I will share the approaches we evaluated and ultimately chose at our organization. Gradle is a well-known build and dependency management tool. One particularly valuable feature of Gradle is its multi-project builds capability, which promotes better code organization and allows independent deployment of the modules. Spring Monolith is a continuation of Monolith's project aimed to structure monolithic application into logical, loosely coupled modules within the single application. For our Kotlin Monolith apps, we chose Gradle with separated Spring application context. This setup met our needs for the monolith while allowing us to stick with technology we know and is mature enough. I have a note about Ruby on Rails here too. We still have a big Ruby on Rails application, and in order to modularize it, there's a built-in mechanism in Ruby on Rails framework. The mechanism is Rails engines, which are essentially mini applications that you can embed into your primary application. Device, well-known library in Ruby on Rails world, is example of such an engine. Also, I want to point out a few books that talk about modularizing backend applications. The first one, Component-Based Rails Application, is the one I read, and the author is actually writing a second book called Gradual Modulation for Ruby and Rails. On the opposite side, there's also monolithic application with Spring. This book is being written by Oliver Drudbom, who's part of a Spring team. I'm really excited to read these two books once they are out. So what are the strategies we can employ to disentangle functionality from a monolithic service? Before diving headfirst into microservices architecture, there are a few prerequisites that you should meet. First is rapid provisioning. Second is continuous deployment. And third, effective monitoring. If any of those are lacking, or if your organization hasn't really adopted DevOps mindset, the microservices architecture might not be your best course of action, at least not yet. So we were sure to address all these factors. We employ infrastructure as a code to provision new resources. We do continuous integration with continuous deployment. And in order to trace requests from multiple services, we use Datadog with correlation IDs. But as a primary Ruby on Rails application, we have encountered a unique challenge. By default, Rails utilizes an auto-increment integer column as a primary key. To successfully extract these models, we found it necessary to migrate to UIDs first. This process involved removing the use of such sequential IDs on our front end, in the business logic, and in external systems such as Elasticsearch. We applied the strangle-fit pattern, which enables gradual refactoring or replacement of a legacy system. This approach involves creating new components that coexist with the old system, slowly assuming its functions. The primary advantage of this method is that it facilitates a systematic and less risky transition, minimizing service disruption and allowing for phase decommissioning of the legacy system. And in order to streamline the transition, we employ feature flagging and run the old and new implementation in parallel. This approach allowed us to gradually roll out the new extracted functionality while making sure we can catch all the unexpected bugs. Also, at Productboard, we are now using GraphQL and Apollo Federation. Each of our distinct services and modules within a monolith each expose their own subgraph. These individual subgraphs are composed into a supergraph and schema API used on our front-end application. The federation allows multiple subgraphs to expose and contribute unique fields into a single type. The router is responsible for executing operation amongst one or multiple subgraphs. The incorporation of Apollo Federation has been instrumental in reducing the complexity of our architecture. This setup allowed us to do changes on the backend while not affecting our front-end application. So far, we have navigated through key decisions and their respective contexts, as well as explored techniques and challenges of extracting functionality from a monolith. But who should make the decisions we discussed, and how should they be made? I'm a firm advocate that any software engineer can make architectural decisions. When you are faced with making such a decision, I would like to share a valuable technique we've adopted at Productboard that helped us a lot. The technique is architecture decision records, which are documents containing the context of the architecture decision, all the considered alternatives and consequences of the decision, as well as review by subject matter experts and groups affected by the decision. Despite this consultation, though, the engineer making despite these consultations, the engineer making the architectural decision retains the final say. So this allowed us to distribute architectural decision making throughout our organization. And in conclusion, the architecture you create will inevitably face trials that test its robustness. And so you should always recognize the impact of Conway's law and ensure your architecture doesn't clash with it. Modular decomposition of a system and the decomposition of the organization must be done together. If you are working with a monolithic application, your first step should be to modularize it. You might want to think about a monolith approach. It sits between microservices and monolith. And when you are making those decisions, ensure clarity about the trade-offs to all stakeholders, not just the engineering teams. Enhance transparency by documenting these trade-offs in the form of architectural decision records. And with that, I would like to thank you for your attention and take your questions. Thank you. So there's a question from Dominik. How do I, as an engineer, know when to write architecture decision record? What is an architecture decision? So for me, architecture decision might be, for example, the use of some library. If you are designing between two libraries, a good way how to actually document the trade-offs between those is to write an architecture decision record. These examples might happen on every day when you are working as a software engineer. So I would actually prefer writing those down and then potentially archiving them or discarding them rather than not writing them first, because the decision you are making might be too small from your perspective. What led you to the decision to go with Java? So our primary stack now for the backend services is Kotlin with Spring. And the main reason is that there's a much wider talent pool in the markets we operate in. And we, for years, have been struggling with hiring Ruby engineers. Also, what we have observed is that the Kotlin or JVM engineers come with an experience from distributed systems, which is invaluable for the company of our stage at this moment. How much functionality you had extracted so far? Can you provide example of service? How many microservices you have now? So I would like to start with saying that it was never our goal to get to some point, to some number of microservices. We've always been very pragmatic of introducing new services. And at this moment, you actually have to go through architecture review before introducing a new microservice. For example, what we extracted so far is a functionality which lives on our insights board and groups the filters you set. We've moved this functionality from our Ruby on Rails monolith to a Kotlin microservice throughout the last year. So yeah. How many modules do you have? Could you share some specific example of a modulate and describe why did you decide to split it away from the rest, and with what other modules does it talk to? At the moment, I would say we have two Kotlin modulates. The first one happened to was constructed because we started actually merging some of the microservices together, and it holds a new storage for one of our models. And the second one is currently being developed, and it will hold the new architecture we are building at Productboard. So in short, I would say two. And for the first one, it doesn't communicate with anything synchronously. So the modulate actually listens on Kafka and streams and listens and gets all the data through it. With having a modular modulate, how do you manage database connections? Does every module have its own connection? So this was something we were looking into when we were doing technical research for our monolith. We decided to go with a shared pool of connections for the whole monolith, but there's definitely an option to either split the have each module have its own connection, or even go further and have each module have its own database. This way, you are actually getting pretty close to microservices architecture with this. So I can get to the next one. How do you ensure that data consistency within the production environment doesn't get corrupted due to releasing new features, sometimes necessary, bringing in the data model changes? I can start with saying that what we are trying to always do are backwards compatible deployments. So in any scenario, it should happen that a release of new feature breaks something which is already in production. But as for the data consistency, we do have some systems built on top of our databases to check for consistency of certain data. But apart from that, we don't do anything special. What is the most challenging aspect of the architecture transition for you personally in the role of a staff engineer? So I'm currently thinking like these 4 years back. I would say for me it was maybe not about the decisions themselves, but the speed of the company. So just to give you in perspective, when I joined, we had single Ruby on Rails application deployed to Heroku. Currently, we are running multiple services on our AWS on top of Kubernetes. So for me, it wasn't actually hard to comprehend the decision itself, but to keep up with the speed of the company. And the last one, I think, is you mentioned Kafka. Do you manage your own cluster or rely on cloud provider? Could you share the motivation behind your decision? So we have a managed Kafka from Confluent. We don't run our own cluster. And we same as with everything, we did discuss which technology we can use. And for us, Kafka made the most sense. It matched the model we were thinking about. But currently, if I would go back, I might actually choose simpler system, because Kafka has a lot of quirks you need to understand, and it's definitely not a simple system to operate, even if it's managed in Confluent. So if you are in a position where you are actually deciding if you should go with Kafka or something simpler, you can go with like Amazon SNS, and it will be much easier for you rather than dealing with Kafka. Do you come across some difficulties with GraphQL Federation? What stack do you use? Apollo Router? I would say the biggest difficulty of adopting GraphQL is the mind shift. We have been working with REST and our implementation of Flux on the front end for the past years. And now every engineer in our company needs to start thinking in Relay and GraphQL. So that's something I would say is the hardest for us at the moment. And as for the stack, what we use, we have our own instance of Apollo server. So we are not using Apollo Router yet, but I would definitely recommend, and I would say even Apollo in their documentation currently recommends using Apollo Router, which is the newer version of an built on top of the Apollo server. But due to some of the libraries and dependencies, we haven't migrated to Apollo Router yet. And do you deploy each module as separate service? So each module can have different dependencies, different scalability profile or resources. This is actually possible with the Gradle setup we have. For example, we have split our modules into a GraphQL module and a Kafka listener module. So the Kafka listener runs on a separate pod with its own requirements on the CPU and etc., while the GraphQL has different scaling profile. Did you see any change in the AWS build switching to microservices approach? Yeah, like our AWS build is madness. But to be honest, check MongoDB builds if you can. I think if you have a managed MongoDB database, it's even higher. At least it's in our situation. But yes, we have many more resources running, and we need to be mindful about this. So, for example, on staging or environment, which we have before something goes to production, we try to manage our resources and keep our bills down. But it's definitely an issue we are dealing with pretty much every quarter. So that's all questions. But I actually enjoyed talking about this topic. So if you would like to talk about this more, I will be around here for the evening, and we can catch up. So again, thank you very much, and sorry for the issues with Slido.